Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of BITSAT Practice, we're going to be looking at some questions of physics which were asked in previous years of BITSAT. Today we're dealing with the chapter Motion in a Straight Line. So this deals with rectilinear motion and deals with concepts such as velocity, acceleration, and so on. And we'll also study the three laws of motion in this chapter. So let's look at some questions which were asked from motion in a straight line. Here is a question from 2017. A particle moving along the x-axis has an acceleration f at time t, given by the acceleration f equals f naught times 1 minus small t divided by capital T, where f naught and capital T are constants. The particle at t equals 0 has 0 velocity. In the time interval between t equals 0 and the instant when f equals 0, the particle's velocity v is equal to. So, how do we solve this question? First, let's look at acceleration. The acceleration is given as f equals f naught times 1 minus t divided by capital T. So basically, we have the acceleration here, and we need to find the particle's velocity at a particular time interval. So we know that acceleration is represented as dv by dt, and so therefore we can write dv, that's change in velocity, as f naught times 1 minus t by capital T into dt. So from here it's easy to find out the velocity equation just by integrating. So v will be equal to integral of dv, and that is equal to the integral of f naught times 1 minus small t by capital T times dt. Now let's split the integral into two parts. Now since f naught is a constant, we can take it out of the integral, and then you have dt, then minus the next term, which is again f naught divided by capital T. Both of these are constants, so they go outside, and inside the integral you have t dt. So what we get finally is v equals f naught times integral of dt gives you t, and then minus f naught by capital T times integral t dt, that gives you t squared by 2. So what we get is v equals f naught times t minus t squared by 2 times capital T plus c. So there's always a constant c, which is the constant of integration. And what we're going to do is we're going to apply the condition the particle at t equals 0 has 0 velocity. So that means at t equals 0, the velocity v is also equal to 0. So when you put those values, you will get v is 0, so 0 equals f naught times 0 minus 0 squared divided by 2t plus c. So since there's the 0 inside the bracket and in the numerator, the whole term becomes 0, so 0 equals 0 plus c. That means the value of c equals 0. Therefore, the equation for v is f naught times t minus t squared divided by 2 times capital T. So this is the equation for velocity. Now, we need to find out the particle's velocity in the time interval between t equals 0 and the instant when f equals 0. So our next job is to find out what is the instant when f equals 0. So when we consider f equals 0, we know that the equation on the right hand side, f naught times 1 minus t by capital T, will also be equal to 0. So when you take f naught to the right hand side, it becomes 0. So what we get is 1 minus t by capital T equals 0. You take minus t by capital T to the right hand side, you get 1 equals t divided by capital T. And when you take capital T to the left hand side and swap them, what we get is the relation time period t is equal to the constant capital T. So at f equals 0, so when the acceleration is equal to 0, the time is the constant capital T. So now we know the instant when f equals 0, and we know the other part, the initial part of the time interval, that's t equals 0. Next, we need to find the velocity of the particle in the time interval between t equals 0 and t equals capital T. So for that, we need to integrate the earlier equation for dv, that's this one. We need to integrate this equation, but this time we need to ensure that we put some limits. So let's consider Vx from 0 to v, that's the velocity in that interval, and on the right hand side you have the integral of f naught times 1 minus t by capital T times dt, and the lower limit is t equals 0 and the upper limit is t equals capital T. Now f naught is a constant. Now what we can do is, since we've already integrated this equation here, and we got the equation f naught times t minus t squared by 2t, we are going to substitute the integral with f naught times t minus t squared by 2t, and t minus t squared by 2t is inside a bracket whose lower limit is t equals 0 and whose upper limit is t equals capital T, the constant. So when you have limits, we first apply the upper limit and then subtract with the value of that lower limit. So basically we have capital T minus capital T squared divided by 2 times capital T, and we subtract that with 0 minus 0 squared divided by 2t. So basically this part turns out to be 0, so you don't need to subtract anything from the second bracket, from the first bracket. But if you look inside the first bracket, you see that the numerator is t squared and the denominator is 2t, so you can cancel out one of the t's. So what we get is t minus t by 2 inside the bracket and f naught outside the bracket. And the left hand side will be v minus 0, so that becomes v. So the value of v, the velocity of particle in the time interval between t equals 0 and the instant when f equals 0, will be f naught times capital T divided by 2. So since t minus t by 2 gives you t by 2, so you have f naught multiplied by t by 2 as the final solution. And if you look at our options, you can see that option C, half f naught t, is the same thing as f naught t divided by 2. So therefore option C is the correct option. All the other options are incorrect because in option D the half is missing, and in options A and B the value of t is being squared, so that's also incorrect. So we solved this question first by integrating the equation to get the equation for velocity, then we found out that the instant at which acceleration is 0 is when the time period is equal to the constant capital T. And then we integrated the equation for dv again, but this time with limits from t equals 0 to t equals capital T. And we got the final answer, that is option C, f naught t by 2, or half f naught t. So option C is the correct answer for this question asked in 2017. Let's look at another question. This one is from 2016. A frictionless wire, AB, is fixed on a sphere of radius r. A very small spherical ball slips on this wire. The time taken by this ball to slip from A to B is one of the four options. So, how do we solve this question? Well, the spherical ball slips under the influence of the acceleration due to gravity. And in this particular setup, G acts vertically downwards. However, the ball does not travel vertically downwards, it travels at an angle theta with the vertical. So the acceleration of the spherical ball, that is A, will be equal to G times cos theta. Let's consider this as our equation 1. Now, we need to find out the distance between A and B. So the distance, that is AB, will be equal to half G cos theta times t squared, which is the time. Now, basically, we use the second law of motion, S equals ut plus half AD squared, but since the ball starts from rest, u equals 0. And that's why we just have half AD squared. Here the acceleration is g cos theta and the time is t. We just took the time as t because in the final answer there is nothing related to it. So, because in the final answer we need to find the time period, so t is important. So we took it as a variable t. Now, let's look at the triangle ABC. So in the triangle ABC, you notice that this is a right-angled triangle, and also the hypotenuse is the diameter of the sphere. And AB travels along a chord. So AB is a chord, and so you need to find out its length. So in triangle ABC, which is a right-angled triangle, the value of cos theta will be the adjacent side to that angle divided by the hypotenuse. In this particular case, the adjacent side is AB and the hypotenuse is AC. And AC is the diameter of that sphere, so therefore its value will be equal to 2r. So the value of cos theta is AB divided by 2r. That means the value of AB is equal to 2r times cos theta. Let's consider this as equation 3, and AB equals half g cos theta t squared as equation 2. So now that we know equations 2 and 3, let's equate them. So equate the RHS of equations 2 and 3. So what we get is half g cos theta times t squared will be equal to 2r times cos theta. So here cos theta gets cancelled out, and let's take t squared on the right-hand side, on the left-hand side. So half, and half goes to the numerator, it becomes 2, g goes to the denominator. So t squared will now be equal to 2 times 2r, that's 4r, and divided by g. So t squared equals 4r divided by g. Now if we were to take the square root of both sides, so t will be equal to under root of 4r by g, And now we know that the square root of 4 is 2 because 4 is a perfect square. And therefore, we can write the value of t as 2 times the under root of r by g. So t is equal to 2 times under root of r by g is our final answer. So if we were to look at our options, you can see that option C, 2 times under root of r by g, is the correct answer for this question, which was asked in 2016. So first we had to find out the value of AB using the second law of motion. Then we found out the value of AB using trigonometry, and we equated the two values, and then we found out the value for the time taken, which is 2 times under root of r divided by g. Now this is the final question of this episode. This one's again asked from 2016. A body starts from rest at time t equals 0, and its acceleration time graph is shown in the figure. We need to find out the maximum velocity attained by that body. So whether it's 110 meters per second, 55 meters per second, 650 meters per second, or 550 meters per second. So how do we solve this question? Let's look at the question once again. The first sentence says that a body starts from rest. Now, when a body starts from rest, it means that the initial velocity of that body is equal to 0. Fair enough. Now, in the course of this acceleration time graph, the body reaches a maximum velocity that is Vmax. So we can consider that as our final velocity. And since we know the initial velocity and final velocity, we can calculate delta V, which is basically change in velocity. That is equal to V final minus V initial. So far, so good. But how can we find out the value of delta V if we don't know V final minus V final or V initial? Well, that's where the graph helps us. You see, this graph is an acceleration time graph, and the area under the graph, that shows us delta V, or change in velocity. So it's basically the area of a triangle, area under the graph. So that means we have to calculate the area of this triangle here. We know that its height is given as 10 because we know that this part, the intersection of the axes, is the origin. So we have a height of 10 and a base of 11. So delta V is now equal to half BH, which is the area of the triangle here. So that's half times, the base is 11, and the height is given as 10. So 2 goes into 10 5 times, so you have basically 5 times 11, which is 55. So V final minus V initial is equal to 55 meters per second, since it's in the dimensions of velocity. Now what we do is we apply the values of V final and V initial. So it's Vmax minus the value of V initial is 0 because the body starts from rest. So the right hand side will now still become 55 meters per second. So Vmax minus 0 is the same thing as Vmax by itself. So the maximum velocity attained by the body, as shown by this graph, will be 55 meters per second. So among the 4 options, it's clear that option B, 55 meters per second, is the correct answer. So the trick here is to use the acceleration time graph, so we will get delta V here, and we can take delta V as the change in velocity between the rest position and its maximum velocity. So after we found out delta V, it's a piece of cake to find the maximum velocity by using v final minus v initial. That's the formula for delta v. And finding out delta v is easy. You just have to find the area of the triangle formed by the graph. So that's half bh, so half into 11 times 10, that gives you 55. So 55 meters per second is the correct answer for this question. Option B is the correct option for this question asked in 2016. Now, that concludes this episode of BITSAT. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a lot of content at Brain Blitz Audios for BITSAT, so if you want to access that playlist, you can always click the link for it, which is present in the description box below. Also, if you want to get updates about our latest content, then please don't forget to hit the notifications icon present below the video and set it to all. So, until the next webisode, take care, stay safe, bye-bye for now.